In this video, we're going to look at how we can write ionic equations when we have reactions occurring in aqueous solution, reactions between ionic compounds. So when you mix two aqueous ionic compounds together, there are two things that can happen. And the first is that nothing happens. The compounds just remain in solution and they don't react. Or one aqueous ionic compound will react with the other and there will be a new compound formed. So these type of reactions are double displacement reactions where the cations exchange anions, and they can be written in this general way: AX plus BY produces BX plus AY. So when you have ionic compounds in an aqueous solution, those ionic compounds break apart or dissociate into their respective ions in that solution. So for example, when you have sodium chloride in its aqueous form, there isn't actually any sodium chloride as a compound in that solution. The sodium chloride has broken down or dissociated into sodium ions and chloride ions, which are floating in the water. And we can write a dissociation equation like this. Sodium chloride aqueous dissociates into aqueous sodium ions and aqueous chloride ions. Another example is if we were to have a sample of aqueous calcium phosphate, it would actually be a solution of calcium ions and phosphate ions in the water. And then the dissociation equation looks like this. So you also need to pay attention to those subscripts and how many of each ion you have. So in this case, calcium phosphate is Ca3PO4 So that means there are 3 calcium ions and 2 phosphate ions, which are aqueous as well. So using this concept of ionic compounds dissociating, we can rewrite double displacement reactions as total ionic equations. So anything that is an aqueous ionic compound gets broken down into its ions. So silver nitrate becomes silver ions plus nitrate ions. Sodium chloride becomes sodium ions and chloride ions. The product sodium nitrate becomes sodium ions and nitrate ions. And then the silver chloride isn't aqueous, it's a solid, so it just stays as silver chloride. So the precipitate, AgCl, has not dissociated into ions because it's not aqueous any longer. It has formed a precipitate and has come out of solution. So this very long equation here is called the total ionic equation. And it's a better representation of what's actually happening because those ionic compounds are actually broken apart into their ions. Now what we can do is look a little more closely at this. So here's our total ionic equation. And you can see that there are some ions that appear on both sides of the equation. So we can cancel those out. So we've got nitrate ions on both sides, and we have sodium ions on both sides. So when we cancel those out and we write down what's left, we get the net ionic equation. Silver ions react with chloride ions to make solid silver chloride. The ions that we crossed out, the ones that aren't in the net ionic equation, are called spectator ions. So in this case, sodium and nitrate. And they're called spectator ions because they're not participating in the reaction, they're really just watching it. Right? They're floating around the solution, not doing anything, but it's the silver and the chloride that are actually reacting together. So what happens when both products are soluble? We've talked about how that's a no reaction, and this is another way to look at that. Right? If we break down all of the ionic compounds, which are aqueous, into their ions, so calcium nitrate becomes calcium ions and 2 nitrate ions, the 2 sodium chloride, 2 sodium ions, and 2 chloride ions. Then the sodium nitrates break down into sodium ions and nitrate ions, and the calcium breaks down, or the calcium chloride breaks down into calcium ions and chloride ions. So then we start canceling things out that appear on both sides of the equation. So we cancel out the calcium, can cancel out nitrate, cancel out the sodium, cancel out the chloride, and there's nothing left. Right? Everything's gone, which means no reaction actually occurred. So this, again, is another way to look at a double displacement reaction and see that when no precipitate is formed, there is no reaction that has occurred.